Common errors in C1. First of all, if this means equals to, then this means not equal to. You'll see this symbol used, or this notation used throughout this video. 2 divided by 0, or anything divided by 0, is not equal to 0. If you divide by 0, you get a number that's undefined, an infinitely large number. 3 squared is equal to 9. If the base is minus 3, and that's squared, so that will be minus 3 times minus 3, because squaring something means you multiply it by itself. So that will also give you 9. But what about minus 3 squared? Now what this is saying is do this part first. So do the 3 times 3 first, and then put the minus in front, so you get minus 9. So to think that minus 3 squared will give you 9, it doesn't. That's another common error. On your calculator, if you want to do minus 3 like this, squared, you must use brackets. So if I want everything inside the brackets, the minus 3 to be squared, I have to do this. On the other hand, if I want to do minus and then 3 squared, then I can do this. And as you can see, this gives you minus 9 and not plus 9. X squared, and then all of that to the power of 3, is not equal to x to the power of 5. We're not adding these. What it does give you is x to the power of 6. You're multiplying the indices. We're using the power on power rule for indices, so you multiply these. 2 times 3 is 6. I've got this single fraction, and somehow I think it's going to split into 2 separate fractions like this. It's not equal to this. This is wrong. And I will demonstrate the same error with the numbers here. Clearly the denominator is 2 plus 8, which is 10, so you've got 10 divided by 10, which is 1. Yeah, the answer here is 1. This is equal to 1. So using the above error, so I'm going to try and split this up into 2 fractions like this. 10 divided by 2 is 5. You can tell that's wrong already. That was equal to 1. I've already got 5 by just looking at this fraction. Okay, so these are not equal. 1 over x squared plus x cubed. What is this not equal to? Well, the common error here is to write it as x to the power of minus 2 plus x to the power of minus 3. This simply is not the case. I'm going to do some cancellation of the fraction here, so I'm going to simplify it, but I'm going to make a mistake, a common mistake, to think, well, the a here and the a here will cancel. This is wrong. The only way the a in the denominator will cancel with something in the numerator would be if you had this, ax plus 3a. So both of these terms had a in them, and we were dividing by a. Now I can do this. That's reasonable. Or perhaps this. Notice in this one I've changed this term here, it's a squared. So again, cancelling here, cancelling an a from the top, from both of these terms, with the a underneath. And dividing by 1 doesn't do anything anyway, so if I had nothing underneath, I mean, that would just simplify to this. This fraction does not simplify to give 1 plus root 3 over 5. So clearly somebody here thought the 5 and the 15 cancelled, so dividing both the 5 and the 15 by 5, so 5 divided by 5 is 1, 15 divided by 5 is 3. I was meant to put a 3 here, so ignore that 5 that was there. This is wrong. You can't do this. This is based on the same principle of why this was wrong. You can't just cancel the a with the a here. You can do this by cancelling an a from both of these terms with the a underneath, but you can't do this. So let's have a look at a version of this which is correct. So let's say if we had plus 10 root 3. Now I can cancel this. The 5, the 10 and the 15, these are all multiples of 5. So if I divide each one of these by 5, I'll get 1 plus 2 root 3 over 3. This is now correct. In this one I have a fraction, root 21 over 7. Root 21 I could write as, what, 3 times 7. All of that over 7. And then here's the mistake, to think that the denominator 7 here will cancel with the 7 that's inside the third. You can't do that. The 7 in the denominator will only cancel with this number in front of the root 21. So this is a different example. And in this one, the 14 and the 7, they're both multiples of 7. So if I divide both of these by 7, I'll get 2 root 21 over 1. And that divide by 1 is not doing anything there anyway, so that would give this. Multiplying out the brackets here. So minus 2x minus 2. We know they're not equal because minus 2 times minus 1 does not give you minus 2. Minus 2 times minus 1 gives you plus 2. Multiplying the brackets out, x plus 3 squared. A common mistake is to think that's equal to x squared, so you put the square on the 3, and you put the square, well, you put the square on the x, you put the square on the 3, so you've got this. That's wrong. X plus 3 squared means you take the x plus 3 and you multiply it by x plus 3, so you're multiplying it by itself, and that will give you a number of terms including x squared, 3x, 3x again here, and 9. So you've got x squared plus 6x plus 9. So you can see that from here you had x squared plus 9, which is 3 squared. So you had these two terms, but you were missing this. This is a common mistake where students are too lazy to multiply out brackets properly. Okay, x plus a to the power of m. So is that equal to x to the power of m plus a to the power of m? No, it's not. Here's a quick reason why it's not, using some numbers. 2 plus 3 is 5. 5 squared is 25. So I know that this is equal to 25. Now applying this to the numbers here, so that power of 2 goes on here and here, so you've got 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9, and that gives you 13. Is 25 equal to 13? No, it's not. None of these are correct, because the answer should have been 25 and not 13. 5 times x plus 1 squared. So can I take the 5 into the brackets here to give me 5x plus 5 squared. No, you can't. The 5 stays on the outside of the bracket. It doesn't come inside like this. What we should have done here is this. X plus 1 is squared, so it's multiplied by itself. So you do this part first. So you've got x squared plus 2x plus 1. All of that's still multiplied by 5. And then you multiply everything by 5. So 5x squared plus 10x plus 5. For the same reason, if you start with 3x plus 3 squared, that is not equal to 3 brackets x plus 1 squared. You can't just take that 3 out, thinking, well, I'll just factorize it and take it out. You can't do that. The reason being, if I use some square brackets to begin with, and then put 3x plus 3 inside, and then I've got the square there, so that's the same, and then I take the 3 out from these two, so these are still equal. And then if I take the square brackets out now, that square will go on the 3 and on the x plus 1. So you end up with 3 squared times x plus 1 squared, which gives you 9 brackets x plus 1 squared. Okay, I'm going to complete the square. So you start with x, you take half the coefficient, which is minus 2, that's going to be squared, and then you take this term and you square it and you write it here, and that's wrong. What you should have is x minus 2 squared minus something squared here, and the number that goes there is exactly what you've worked out here. So this value should be in here. So now you've got x minus 2 squared, and if you do the bit in brackets first, minus 2 squared is 4, and then this will give you minus 4. So you can see that the problem here was the sign. It should have been a minus, and we put a plus. I've got this quadratic equation that I'm going to solve using the quadratic formula. So a is equal to 1, that's the coefficient of x squared. B, the coefficient of x, is minus 2. And c, the constant, is equal to 3. So far, so good. And putting all this into the quadratic formula, x is equal to minus b plus or minus root b squared minus 4 times a times c, all divided by 2 times a. Can you spot the mistakes in this? Well, the first one is here, and the second one is here. So this is wrong. This is how you should show you're working out. That minus 2, along with all the other values, are best kept in brackets everywhere. So that minus 2, and in the formula you note x is equal to minus b, so there should be a minus here. So now we have x is equal to minus b, which is correct, plus or minus root b squared, and the difference between these two is that the minus 2 here squared would give you minus 4, but the minus 2 in brackets squared will give you plus 4. So you'd get different values from these. And just to quickly demonstrate that, minus 2 squared gives you minus 4, and minus 2 squared gives you plus 4. So b squared minus 4ac, all in brackets, divided by 2a. So we've cleared up the problems here and here. Let's say we're trying to solve this quadratic equation. So assume that we're going to use the formula next. So we need the values of a, B, and C. So A is 1, B is minus 2, and C is 3. This is wrong because to solve the quadratic equation here, the whole thing should have been equal to 0 first. So if I take the minus k to the left-hand side, you get this. So now it's all equal to 0. A is equal to 1, B is equal to minus 2, and C is equal to, well, C is the constant. It's all of this. It's best kept in brackets. 1 over 2x cubed. So would that give you 2x to the power of minus 3? Because that's a positive power there, and that's negative, so we've taken that into consideration. But this is wrong. What you see here is a half, and what you see here is 2. If that's a half, this should be a half as well. The right way to do this would have been to say that 1 over 2x cubed is equal to a half x to the power of minus 3. 2x cubed, so is that equal to 2x to the power of 3? I mean, that's a common mistake. It's not. Reason being, that power of 3 goes on the 2 and it goes on the 3. What I should have is 2 to the power of 3 times x to the power of 3, which will give 8x cubed. I'm going to write down the equation of the line that goes through this point with this gradient. So y minus the y-coordinate is minus 2, is equal to the gradient, x minus the x-coordinate. So where's the mistake in this? The mistake is here. When I said y minus the y-coordinate, I should have written y minus 2, which gives you y plus 2 instead of y minus 2. So this one was wrong. This is what I should have had here. I've got 2 points A and B. The gradient of the line AB. So let M represent the gradient of the line AB. So change in y, 7 minus 5. 7 minus 5. That's the change in y, so that's good. Divided by the change in x. 2 minus 1. 2 minus 1. 7 minus 5 is 2. 2 minus 1 is 1. So the gradient's equal to 2. This is wrong. Let's go back to the beginning. To work out the gradient, you do the change in y. So if I'm starting with this y value here, so that's the first number that I've started with. So I've started with point B. So 7 minus 5, which is good, that gives you 2, that's fine. Divided by the change in x, I should come back to point B first. It should be 1 minus 2. These are the wrong way round. So what I should have had is 7 minus 5 over 1 minus 2. 7 minus 5 is 2, 1 minus 2 is minus 1, which gives minus 2 as the gradient, not this. I've got the expression 4x squared plus 8x plus 6, so they're all multiples of 2, so if I divide by 2 throughout, so I've got 2x squared plus 4x plus 3, so is this now giving me this? Can I actually do that? Can I have an expression like this and just divide by 2 throughout to get this? You cannot do that. That's wrong. If I want to divide all of these by 2, it's an expression I will be forced to write times 2 on the outside like this. This is now correct. 2 times 2x squared gives you 4x squared, 2 times 4x gives you 8x, and 2 times 3 gives you 6. That's correct. Had this been an equation, so if I had 4x squared plus 8x plus 6 equals 0, then that wouldn't be an issue to divide by 2. Then I could divide every term by 2, so 4x squared over 2 is 2x squared, this gives you 4x, this gives you 3, 0 divided by anything is 0, that's fine. But you can't do that with an equation. You can't just divide by a number throughout and then ignore that. Let's say you completed the square to get to this stage, and you're about to multiply out these square brackets. So that 3 times that part there gives you 3x minus 2 squared minus 5. So is this equal to this? It's not. It's a common error because that 3 should have been multiplying here and here. 3 times minus 5 gives you minus 15 here. Y is equal to minus x minus 3. So would that be equal to, and if I take that minus to the front, would I get this? It's wrong. You don't. What I should have done is y is equal to, and if I'm going to put the minus there, so I'm sort of factorizing here, x, that should be plus 3 all over 2. And if you want to check, minus, it's like a minus 1 there, times the x will give you the minus x, and a minus 1 here times 3 will give you minus 3. So that's correct so far, that's good. And that minus now we can put at the front like this. So you've got minus that fraction. This is correct, that's wrong. Y is equal to 1 over x cubed plus 2x. This example is on differentiation. Dy by dx is equal to 1 over differentiating x cubed gives 3x squared, differentiating 2x gives 2. This is completely wrong. You cannot differentiate x terms which are in the denominator. What we should have done is rewritten this term as x to the power of minus 3, and then you've got the plus 2x, and then if you do dy by dx, the power comes to the front, so minus 3, x to the power of, reducing the power by 1, gives you minus 4 plus 2x. And if you want to, you can rewrite this as minus 3 over x to the power of minus 4, x to the power of plus 4, that's a minus, that's a plus, plus 2. X shouldn't be there, my mistake. Okay, so this video has demonstrated some common mistakes that are made in C1, and there will be a second part to this with more common mistakes that are made in C1. The purpose of the video is to use it near the exams, because a number of topics inside here, if you're looking at this before you've completed the course, you may be unfamiliar with some topics. So a good time to go through this would be around November, December time.